In today's video, we're going to tell you all about how to write the equation of parabolas in standard form. Okay, so what you can expect in this video is a quick reminder of what the two types of standard form look like for parabolas. All right, and then we're going to give you three examples. In our first one, we're going to give you the vertex and the focus, and just with those two things, we're going to write the equation of a parabola. And then the next one, we're going to give you a vertex and a point on the parabola, so on the curve of the parabola. And then in the last one, we're going to give you the focus and the directrix, and then write the standard form from that, okay? So there's timestamps in the video player down below. You can drag it to whichever one you need, but otherwise, let's get into it. All right, guys, so a real quick reminder about what standard form looks like. Remember, there's two different types. Either our x values are going to be squared or our y values are going to be squared. Otherwise, these are pretty much identical, okay? Besides the fact that these two kind of switch when we go to our other type over here. Okay, so let's just kind of run through this. If our x values are squared, this is either going to open up or down, okay? In fact, it's going to open up if our p value right here, this term in front of this parentheses, if that's positive. If it's negative, it's going to open down. And then also HK, just like with circles, HK isn't going to be our center, but it's going to be our vertex of this parabola. Okay, that's still true over here, HK. However, you have to be a little bit careful. Make sure you get the H with the X and the K with the Y. All right, otherwise, this one's going to open left or right, and then right if it's positive, and left if our P value is negative. Okay, let's get into number one. All right, number one here, we want to write the standard form of this thing given our vertex of -4, 2, and a focus of -4, 5. So real quick, I like to either mentally kind of plot this on a grid, or, you know, if you need to draw this out, that's fine as well. Just to kind of get the orientation of which way this is going to open and so on. So first off, -4, 2 is back 1, 2, 3, 4, and then up 2, just like that. And then that's our vertex, our focus at -4, 5. Is still back 4, but this time it's up 5. 1, 2, 3 more. So 5 total, which means this is going to look something like that, give or take, right? So it's going to be opening up. And that's important because this tells me a couple key pieces of information. First off, the vertex, this is always going to be our HK, right? Secondly, this opens up. That means that my x values are going to be the ones that are squared. And so let me write out just the general form of that equation. Okay, so I have almost everything I need except for one value. And if you notice right here, I can just kind of plug in my H and my K. And when I do that, all that's missing then is the P. Well, our P value is the distance between our vertex and our focus. And it's positive if it goes up, negative if it goes down. This one is going up, so this is going to be a positive 1, 2, 3. So here I can replace P with 3, my H and K with the -4 and 2, and I think that's enough to write my equation in standard form of this parabola as the following: x plus 4, right, minus a -4, be x plus 4, quantity squared, equals, and then instead of 4p, I need 4 times, well, this value we said was 3, 4 times 3 is 12, and then y minus my k, well, my k is 2. All right, and that is not squared over here. Only the x's are squared. So this right here is the equation of this parabola in standard form, given our vertex and our focus. All right, guys, for number two, I know I promised you one with a vertex and then a point on our parabola, but this one says it's a maximum at 4, 3. There's still a point on this parabola at 5, 2, but then it also has a vertical axis of symmetry. So is this really what I promised you? Yes, it is, and I'll show you why. Because if something has a maximum with a vertical axis of symmetry, well, maximum means it's the highest point, and then a vertical axis of symmetry, of course, means I could fold it over on top of itself. So this point up here, the largest point, or the highest point you might think for this, is actually going to be our vertex. So we can replace maximum at 4, 3 with a vertex, just like that. And remember, that's our H and our K value. All right, so now we need to use the rest of this information to help us find the equation of this in standard form. So let's start by writing out what this would be. Remember, since this opens down, this is going to be one with our x values coming first. And so we know the standard form of that is this. Okay, so then what I can do is I can replace my H and K with the HK in the vertex that I know is that maximum value. So if I do that, that's going to be x minus, here my H is 4. All right, that's still quantity squared, equals 4p. I don't know anything about that quite yet. We're going to get there. And then y minus k, well, my k is 3, so this will be times the quantity y minus 3. All right, then what I have to do is use that other piece of information I'm given, which is the point on my parabola at 5, 2. Well, this is just an XY point. This could be any point that's on that curve of the parabola. So we need to plug it in for our X and our Y. And you'll notice when I do that, the only variable to be left would be the P. And I can solve for P then. So I'm gonna do that real quick for you. All right, and after solving for P, plugging in my 5, 2, right, eventually solving here this for P, I got -1/4 is P, okay? So what I have to do with that now is plug it back into kind of this second line right here where we already had our vertex in there, but now I'm gonna replace my P with -1/4. And so let's see what that would look like. So let's see, we have x minus 4, quantity squared, equals, and then 4 times P. Well, 4 times a -1/4, if I do -1/4 times 4, here the 4s are going to cancel, leaving me with just a -1. So I can say equals -1 or negative times the quantity y minus 3. And then this right here is the equation in standard form that goes through the vertex, or through this maximum at 4, 3, as well as the point 5, 2. Right, guys, last problem here, number 3, says we have a focus at the point -1, 5, as well as our directrix is going to be the line x equals 3. Okay, so we have to write the standard form of this parabola that satisfies those conditions. So real quick here, I'm going to plot the point -1, 5. That's going to be back 1, up 5. You might be able to even do this mentally, possibly in your head, but to show you what's going on in my head, I have to write it out on the board, right? And then our directrix is at the line x equals 3. Well, that's in the positive direction, 1, 2, 3. And this is a line, I'll use a little dotted line here to help us with that. Now, if you remember, our vertex is the same distance away from our focus and our directrix at all points, including at a line that would be the axis of symmetry, which is perpendicular to our directrix, right? That makes a right angle. And so right now I'm seeing I have 1, 2, 3, 4 units, I guess, spaces in between those two things. So if I go back to this way or back to this way from either one of those, that's going to put me at the point 1, 5, right there in the middle for the vertex of this parabola. So I can also say that the vertex is the point 1, 5. Okay, that's important because that's going to be my HK, right? We need an H and a K when we write the standard form of parabolas, so that'll come into play. And then I also know that if this is the focus, the parabola is kind of opening around my focus, right? That's how that works. And so since I start from my vertex and go back 2 spots, this is going to be a -2 for my P value. All right, my P is going to be a -2. And then because I have a P and the vertex, that should be enough to write the standard form of this equation. We just have to remember that since this is opening left or right, in this case left, this is going to be one where the y values are written first, and those are the ones that are squared. So the standard form usually is y minus k, quantity squared, equals 4p times the quantity x minus h. But here, if I replace my hk and my p with what I know, then it's going to be y minus 5 for the k value, quantity squared, equals p, we said was -2, so this would be a -8 times the quantity x minus h, in this case x minus 1. All right, and this is the standard form of this parabola that satisfies those conditions. Hey guys, if this video on writing the standard form of parabolas helped you out, please help me out by subscribing to my channel, liking this video down below, right? And then you guys also might find this video helpful as you do more parabola problems. Okay, we'll see you in the next one.